Yeah, on your. Yes. Bienvenidos a esta sesión.
Hello.
Bienvenidos a esta sesión que es API4Future, a journey how to create a stable API, a cargo de Marco Schulz. That's how you pronounce it, right? Or how you pronounce it?
Hello, everybody. Yeah, thanks for having me here at Barcamp 2022.
Agradecemos el apoyo de nuestros patrocinadores, JetBrains, Avatar Tech, ERC, Stream Developers, Synergies, la editora MLBI y la Pontificia Universidad Católica, Madre y Maestra. Les recomendamos usar la funcionalidad de preguntas y respuestas que deseen hacerle a nuestro charlista. De esa manera podemos leer en orden y no se pierden en el chat. Las preguntas las pueden hacer durante la sesión y yo, el host, la voy a estar colocando en el panel de preguntas para que podamos responder al final. Gracias una vez más por estar con nosotros y demos inicio a nuestra charla. Thank you, Marco. You can start now. I'll stop sharing my screen.
Hello, everybody. Yeah, thanks for having me here in Barcamp 2021. Yeah, I will share first my screen. So, yeah. So, yeah, I'm Marco, and I'm working usually as a independent programmer, build manager, configuration manager, and release manager in several projects all over the world. My main topics are in general all these things about build management. Today I'm like to present something about API usage, because often in projects I'm joining there's some issues with stable APIs, because they always get trouble. In this way we have to find ways to make it better without having too many problems, without having too many of the instabilities, and how we can change that. For this, we are having here several points we want to walk through. First, I will give some sample APIs and show what is the problems with these APIs. After this, we have a look on some design patterns. They are really helpful to create a stable API. So then we are allowed to, or we are able to replace libraries they are in our code without too many issues. Of course, very important for dealing with APIs is change management and maintenance. So we will have a look how we can do with our Java code a little more stable APIs, that they don't cost us too many troubles when we need to adapt something. And of course, every API have to somehow and documentation. In this way, I will have a look on API Guardian, a very nice programmable documentation inside of the code. And I want to introduce you a little with this. Last but not least, we have a short look into RESTful APIs and Swagger, because this gets more and more popular, and this kind of APIs, they are a little different than regular ones. So for this reason, let's start with the different API types. Usually here there are three common examples we have when we are, for example, dealing with XML, the extensible markup language. And there's one thing, as first, XML itself is very well defined, but the problem is the way how to use in your project XML. There are different possibilities. One is, for example, you could use the Sax technology, or DOM, or Stacks, more new, the Stream API for XML. Of course, everything of this, every technology have a different usage. No? Especially Zax is more event-based. DOM objects or the DOM technology is very needs a lot of resources. So this is problematic when you're dealing with very huge XML documents. So in this way, you will have troubles when you're using your project XML and you need to change, for example, from DOM to Zax, because the usage is completely different. Something equal we have with JDBC, the Java Database Connectivity. So we know, of course, JDBC is a standard, but every maintainer of a database have a own functionality they put inside of the JDBC. That means for us, of course, if I use, for example, in MySQL, special features like auto increments or other things, they may not represented in other JDBCs. And in this way, you cannot simply exchange your underlying JDBC driver for your specialized database. In this way, to keep here stability, you should always try to avoid a database specialized functionality. This you will also see if you're dealing with Hibernate. No? The idea of Hibernate is something you could replace or you can change without any trouble, usually without any trouble, your database system. But the real problem of this is, if I use native SQL in my Hibernate project, inside of this, there is, for example, some Oracle optimizations. Then it's not so easy to replace Oracle, for example, for a Postgres. This flexibility to change databases could be in this way interesting, because maybe you have a lot of, or you need to save a lot of money when you wanted to use in your development infrastructure, Postgres standard, and of course then later in production just switch to the Oracle. But this just works in the way like you are avoid Oracle specified specialized functionality. The same we see with PDF. The thing is, PDF is a standard, of course, that describes the final document. Every created PDF with a regular PDF implementation viewer, you can have a look on it. But one thing is, for example, if you use the iText PDF library, a very common one, and you want to replace it for OpenPDF, for example, a fork of iText, is not that easy because I have a complete different internal API. I was doing this once again. This was caused me a lot of troubles because iText is very specialized. If I want to replace my API for another implementation, if I do some preventing things before, I will not have that easy chance to do that with minimal work. So one thing we could do as first that we can deal more easily with APIs is using design patterns. There are 3 very common design patterns. They could help us in this way. The most typical is adapter. So this is quite simple. In the end, we connecting 2 APIs. They are not compatible to each other. It's like connecting. Another way is a facade. With a facade, I can place multiple interfaces together to a more simple one. This, for example, we could use when we remind in the XML technology. We could here combine different types of stacks, Zax, and DOM. This could be hidden behind a facade. Another way is proxy. This is something like a complement of a facade. No, that means, this is something you combine simple interfaces into more. The way is when you use it, you have more flexibility in your code. I will show you what it means. Here we have in the code, for example, the PDF renderer. There you can see something. Wait, let me check that it's more easy to read. So, okay. So here we have several functionalities. They are defined in an interface. No? One thing you could see here is PDF document, and this usually is coming from external library. But when you see here my internal, I use this PDF document in a own way, because if I would use the PDF document from the external library I deal with, I have the problem I cannot really change here something, because always when I want to replace, for example, the method of remove page, this depends on PDF document as a return value and also in the signature. And to not always replace here something and provide several overloaded methods, I have here a possibility to say, okay, the PDF document I'm using by my own comes here in the end from the open text library is the PDF reader, and I'm just use inheritance. I extend the PDF reader to PDF document. Of course, I don't need to implement everything again by my own or make it too sophisticated. The only thing is I need here two different constructors I want to deal with. And these two constructors I have, you see, I'm just use the super and I instantiate. That's all. And like this, I can use now here in my code a class called PDF document. It's completely decoupled from the library I'm using, because PDF document is something hidden. It's not so probably available. And in this way, I don't have here any trouble to replace something, because you have to keep in mind, if I do an API change for the PDF library, like I was doing, replace iText, I have to change all these methods. They are dealing here with PDF document. This was really a very heavy pain. There are some other things you have to keep in mind when you do that. One thing is, for example, if you have a method like here down somewhere, when they are like this, the load document. If I have to change here just the return value and there is nothing else in the parameters, I can simply not overload. The only way to provide here is a new method. No? So we have to give another name, not load document, maybe read document or something else, because I don't have here any change. Method overloading just works if I change the signature. The return value is not part of the signature. This is one of the things. And to avoid all these troubles is very helpful. To decouple all the components and all the classes. They are not part of your own code. So they come from somewhere else, from a third-party library. You can see that here, always, if you check the interfaces, there's not coming something from other...
I'm sorry, Mr. Marcos. Some people write in the chat.
There we see a next thing. What helps us to deal very well with APIs is having a good architecture. I usually have I work more with layered architecture, and in this way I have two very important layers for me I'm dealing with, is the business layer and an application layer. This is what you can see here in my applications, because I always use these structures in my projects. Now you see here a project called Core. This have a package called application. This have a package called business, domain, like you can see it here in this graphic. And for us, in the way of dealing with API, the business and the application layer are the important or interesting things. Why? The business layer itself contains just my, how I can say, my interfaces, abstract classes, nothing of the implementation. The implementation itself, you find here in the application layer. They are hidden here. So in this way, if you have this structure, for developers, it's more easy to join to a project and they get more fast into productive code. When we have this possibilities of structure, for example, I was here talking about the PDF document class. This is not that regular available in application layer, because I want to hide some additional information. For example, here I have the PDF document. There I have some other stuff with PDF. I have here something with the Zax document handler. And these classes, I don't want that consumers of my API using these implementations, because these are helpers. And for exactly this way, I'm mark inside of application another package called internal, and everybody is using this way these classes outside. Of course, you have to get to know, maybe with the next release there is dramatically changed behavior, or these classes don't exist anymore, or they are renamed, or whatever. And exactly for this reason, it's much more secure that we don't consume these classes there inside. And for this reason, I always say here, application helper or internal to market, really don't use it. When you're dealing since Java 9 with the modularization, you have other possibilities to hide this special helper package. It's more easy for you if you are dealing with that. But the biggest problem is the Java modularization. Is not or not all the libraries we are in general using. They already transformed for ready for modularization, and in this way you get some troubles. Maybe it takes a few years more until everything is productive ready. Another thing, what we are talking about, maintenance, is how to give good names for your interfaces and your implementations. And here we have a look on the Java Standard API. What you can see, for example, there is always a list, or there is an interface called list, the way of how to deal with lists from the collection API. Of course, this interface is not named iList or list I or something like this. No, it's simply list. And the same, the implementation for that, no, it's called array list. So this gives a very good hint for what I'm doing there. So I have there an implementation of an array list. The same we can do with our code. When you see here, for example, I have there in the business the PDF functionality. Now I call my interface PDF renderer. But of course, the implementation, I don't call PDF render implementation. I call it like here, open PDF renderer. And this helps me if I want to make some changes. For example, in concrete, for me, it would happen when I was replacing iText. My interface always was called PDF renderer, and I was having an implementation for iText PDF renderer. And of course, this means I was very easy able to add a new class with the name Open PDF renderer. And there I just was having them the implementation in parallel. If I call my implementation class just PDF renderer impl, how I want to call then the other, impl2, is not so nice. We always get an idea what kind of implementation we are using. In this way, I always recommend to stay in this way, use a proper naming. Don't deal with this prefix or postfix like I or impl, because this can cost you in future when you have to change something or replace something, a lot of troubles. Yeah, in my perception, implementation class with the name iText or PDF render impl2, they don't say nothing about what happened really there. For this reason, keep it in mind. Name your things, your interfaces very general, and the implementations class give a hint about the specialization, what has happened there. With this, we come to the next.
Sorry, Marco, Mr. Marco.
To change.
People are saying if people
API Guardian, there is it's a Java library, very easy to use. If you are dealing with Maven, you just use there this dependency. It's mentioned here, or with Gradle in this way. You just have to add to your POM or your Gradle file, that's all. And then you can use it in your code. Let's go back here to the PDF renderer to show what I'm doing, because I use this library always in the interface classes. It's nothing else than just here, this little annotation. You can see here it comes from API Guardian. So this annotation have several parameters. You can say the status of this. For example, here we say it's stable. That means, of course, I don't plan to give there quite soon a change. If I start to implement something new, I could maybe mark this as experimental. Or later, when I know this will in the future removed, I simply place it deprecated. The next is here since when I have it, and I use it here in the version since version 1.0. This is another hint I want to give if you're dealing with artifacts and you have their APIs inside. Have always a look in semantic versioning. Don't give these version numbers 1.0.5 build number or something. This don't help you. Semantic versioning defines a very easy, understandable version number. Now, if you have there a major change, then you know there is something incompatibilities with your API, and you have to take care. Because the point is, when I provide an API, I have consumers, and that means the consumers have to get informed before I do this API change, that they know what kind of work they have to see in future. Then they can make a plan. If there is in a new major version, I change dramatically, like here the PDF implementation. They know, okay, we are not dealing with PDF. For us, upgrade the major version is not problematic. We don't have too much work. On the other hand, if you have a lot of PDF things in your code, maybe an update of the major version with the new API could take you a few days. This helps you planning. Another thing, what we are doing here in consumers, we say what is the implementation class or the standard implementation class for this. With these annotations, you are quite fine, because you can see that here everywhere. In my methods where I place it, for example, here, write document is available in version 3 of this core library. And This, how it's used, you can see in the test cases. It's very easy because we have here the application, and there is always called some methods, no? Like here PDF, our open PDF implementation. There's load document, and voila. When I go here to this method, I already have here in Javadoc a very nice information about this method is available since version 3, and it's marked as stable. So this helps me as a developer more easy to decide, okay, this is quite fine, this will be stable, and in future I should not have so fast problems. But of course, always think in the law of Murphy, the things they can change, they will change. So it's a little, nothing is so sure like the changes, no, they are coming in an application. With this, we want to have a look into RESTful services. They are very, very common nowadays. RESTful services, they're a little different than standard APIs because you provide URLs, resources. In this way, you have to think a little different because every version of your service, or you have to put versions in your service. That means you have to increase, for example, the version number. Let's see it like here. Here I have from a project ACL called, it's also available, everything you see here in the code in GitHub. There is a path I place together, the standard, it's ACL. Then I say here my REST API version. In this case, this constant is binded to number 1. And then there I have the resource in this way. It's called role. This is my standard resource pattern I use. When I need to increase this version is just in the case when something I already was having in my API is not there anymore or changed somehow. Because like this, I have to mark it. As long as I just put things on top, creating new methods there was not there before, your consumer of the API don't have any trouble because they don't need to adapt something of the previous code. But in the case you have some problems, and you want to add or you need to change an already existing method for some reasons, then you have to increase here the API version. And it's just a regular auto increment or incrementing, no? For me, this don't need the semantic versioning because this is getting simply too confused. Let's see how we are, for example, able to define a role. For example, here we have somewhere a code, delete a role, comes with our new path. That means I have to place there the role. And I, of course, have here several possibilities. No? For example, my role is fine and everything was working and I was able to delete. I set back the 410 status, HTTP status code, because this is related to delete. In the case I was not having, or the role was not existed, I was wanted to delete, I can send back a 404 that says, yeah, this role was not existed. And of course, if I have not the right to erase the role, simply it's quite nice. I'll just put there 403 and say, yeah, it's forbidden. And this is the implementation of delete role. Or here, if I have some exceptions, I could give there some status codes like a conflict or whatever happened there. This gives us a lot of helpful things inside of the implementation, or if I use it. When I use this method in my client, I always know what happened, and of course I have to check these codes and to see what happened. In this way, I defined as first the API, and this API we can watch here with Swagger. Swagger is a tool you integrate in, for example, here in your Maven POM. I have it here. More down, you can see you just place it as a plugin. This you can see, maybe there, it's better to read. The Swagger Maven plugin. This just tells me which package they have to observe. This is here the ACL service, because this is my implementation package for all the RESTful services, and here they goes out. And then I get something like here in this presentation. This you can see in your browser. There is running in the background a Docker, this Docker container called Swagger UI. And this is loading here this small JSON file I create during the build. There I see all the possibilities of my RESTful API. And if there is running a server in the background with the services, I could try out here directly in the way like, I just click there inside and I say, okay, try out here. And I place a JSON string of the role I want to erase. And I execute, and then I say, okay, it's working fine. In this way, we have here other things, or other way to deal with an API. You see RESTful services a little different. Very nice of Swagger UI is you see here the JSON schematas, the objects you're dealing with. In this way, you can use it more easily in your clients. Then let's resume everything a little together. What we can do to create a really helpful standard API. This is robust and don't cost us too much troubles when we update. So as first, implement everything against interfaces. We already saw. Another very important thing is use the KISS principle. Keep it simple, stupid. As more complicated the things got, as less fun you have. It's easy like this. Always try to take standards, even with your structures. No? The point is, for example, here the architecture, the layer architecture helps a lot. The standard of the Maven directory structure helps me a lot to get very fast, productive inside of a project. Name your interface very in general. Name the implementation very specialized, now like iText implementation or Open PDF implementation or Java cryptography or whatever you use. Document your interfaces very well. You can see that here, especially in the PDF renderer, all these Java docs put there really good descriptions. This helps a lot. If you do that, the people will more enjoy to deal with your interfaces, and you're secure that they are using that in the correct way. One very important thing is if you are dealing with API changes, package them together in a one release, and don't bring them all the time with every second or third release, because this shows some stability of your planning, of your work, of your project. Maybe don't or maybe make a API change just once a year or maybe twice a year, but not more often, because that shows your consumers they have to do a lot always to adapt the changes. So in this way, also take care of compatibility. If you know in future there will come something, use the annotations and tell them, there will, with this functionality will comes in the future some changes that the developers can handle with care. So yeah, that was my intention of how to use APIs. It's getting confusing. I always hear myself. And how to create stable APIs. And in this way, I hope you was getting a lot of helpful recommendations. If there's some questions, I'm open to answer. The presentation slides you can find later in speaker deck. For this, I will publish in Twitter. You can find me Elmar Dot in Twitter. That's
Mr. Marco. There's actually a question here from Lizzie Boney. She says the following: you talk about stable APIs, but I seem to miss the role testing and testing frameworks play in a stable API. What do you suggest in this respect?
The testing frame. Wait, I have to mute myself. So no. Okay, one of the problems is when you deal with different frameworks, you always should try to wrap the functionality you're using. Now, like I was showing here with the PDF, because in the end, the PDF is a library. If you deal, for example, with Hibernate, you have this, what I was mentioned with the GDBC. Always move back to standard functionality, always move back in ways of using design patterns. They help to wrap the functionality you are using. And of course, there are some frameworks like Spring you cannot simply replace. This is almost impossible. Yeah. This fit your question?
Yes, that was a question from Lizzie Boney. It seems that there are no new questions from the audience right now.
In the case there's some more questions in future, you can contact me in Twitter. My Twitter handle.
So, si hay más preguntas para Marcos Schulz, pueden contactarse a través de su Twitter, lo colocó en el chat, elmar.dot. Pues sí, muchas gracias por habernos acompañado en esta sesión. Agradecemos su colaboración.
Muchas gracias.
Thank you, Marco. We really appreciate your support. It was a great session. Thank you.
It was a pleasure to be here. Gracias. Okay.